Oops. Hey guys, BuildZoid here, and as you can see, we've got a 980 Ti reference card on the hot plate. I mean, I have a bit of paper under it because the hot plate itself is kind of covered in flux residue, and I don't like getting it all over things, but yeah, we've got this reference 980 Ti here. I bought this card on eBay for like 25 quid. It's dead, of course, that's why it's 25 quid. And in typical 980 Ti fashion, it has a Vcore VRM failure, but, oh, actually, I can already see which power stage we're replacing as this one. Yeah, with the extra lighting, this thing, yeah, so this one's getting replaced. But I'll pretend that I didn't notice that this one is bulging in this area. I'm not sure if you can see that on camera. Actually, I'll try to zoom you in. Hopefully I have the autofocus on. Where's the zoom? The camera's upside down. Oh. So, there. So, this power stage has a slight bulge to it. So, basically what happened is it shorted out and then vaporized internally and, kind of blew the packaging a bit. It's not very obvious, though. Anyway, there's another bit of damage over here-ish. We have this MOSFET with a little burn mark in it, so we need to replace that. Yeah, we'll have to replace that. This is the current balancing for the 980 Ti. On one hand, when the card fails like it has failed here, this is actually acting like a bit of a fuse, and it's somewhat limiting how much damage the failed power stage can do, but on the other hand, it would be better if you just had fuses instead of, and also some of the phases are connected directly to the power connectors, so if those blow, those just absolutely crater the card. Zoom out again. Like, it's pretty typical that, like, if this or this power stage, and these like to blow up a lot, especially on the, like, EVGA 980 Ti reference, EVGA has the two-fan 980 Ti reference PCB with, like, a EVGA designed heatsink. That card, because the VRM cooling on it is terrible, and it's especially bad on the bottom edge right here, these two power stages on those cards are super liable to fail, and when they do, they absolutely destroy this area of the PCB because there's no fuses or anything, so there's just, yeah. Anyway, we're gonna pretend I didn't notice that failed. And, like, we're going to pretend that we didn't have visible damage, which you don't always have with failed power stages. Like, sometimes they'll fail and you won't see any obvious signs. So, we're going to pull out the multimeter and do this the sort of what if you can't see what went wrong sort of way. Because, yeah, that's a bit more useful than just going like, oh, I can see the damage, therefore I can fix it. No, like, what if you can't see it? Okay, I guess we're going to end up with the multimeter. Okay, well, at least it's legible. So we're in resistance mode. This camera angle is not... Like, either I can see what I'm working on or you guys see what I'm working on. This is why I don't try to do... Maybe we can do it like this? Oh, wait, the multimeter's upside down. Well, actually, we can just put it like... No, that's still not really... I need a shorter multimeter is what I need. There. So we're just going to go and check the shunt resistor, use the shunt resistors for our resistance checks. So one of our black probe for ground is going on a, I mean, I like DisplayPort casings. These are just a nice place to grab a ground, so we're just going to go off of the DisplayPort. And so if we check, say, the Vcore VRM right now, we're going to see that this core has 2.5 ohms of resistance, which is pretty normal for a 980 Ti to have 2.5 ohms of resistance. This chip is pretty big, so you'd expect it. Like, it's actually kind of funny that, like, there's other chips that are smaller, or even, well, like, modern GPUs will typically have even less resistance than this does, but yeah, 2.5 ohms for a 980 Ti is a perfectly healthy resistance for the chip itself, so that's good. The memory has a resistance of 65 plus ohms. That's perfectly good. Then we check this shunt resistor over here, which is one of the 12-volt rails on the card. That's measuring kilo-ohms range, so that's good. We check this shunt resistor over here. Which side of the shunt resistor you check doesn't matter. And this one is very shorted out, right? We can see 2.5 ohms. So what's happening on this shunt resistor is this shunt resistor is going to be connected to that blown out power stage. So that power stage is connecting the core directly to this shunt right now because the power stage has an internal short circuit, which is pretty standard. If you have a VRM fail, the high side MOSFET failing closed is sort of the standard failure. In my experience, like it's very rare that you see a VRM where the high side MOSFET doesn't connect the 12 volts to the output. The problem with this, of course, is if you power cycle the card, every time you power cycle the card, you're connecting 12 volts directly to the chip. Now, on Vcore, this isn't generally too much of an issue because the chip has a very low resistance, so the current, like the voltage doesn't ramp up as quickly as, say, on the memory. If you have a high side MOSFET failure on the memory, it typically destroys most, if not all, of the memory chips and potentially the GPU's memory controller very, very quickly. Even then, if you power cycle a GPU with a dead Vcore MOSFET like this enough times, eventually you will kill the silicon. So that's kind of like if you had, and that's the main benefit of fuses is like the fuse would not blow until this power stage has destroyed itself. But after the power stage has destroyed itself, the fuse would prevent you from sending 12 volts to the silicon. So hopefully this card hasn't been power cycled a bunch of times, but based on the fact that this isn't completely annihilated, I'm going to go with that this probably hasn't been power cycled a bunch of times. So yeah, anyway, we now know that there's like a short circuit on the parts connected to this MOSFET over here. I mean, this shunt resistor over here, and if we check this shunt resistor, we have like 300 kilo ohms, perfectly safe. I think this is our 5-volt rail down here. Yeah, and that's at 1.6 kilo ohms, so that's probably 1.5 volts. Down here we have a PEX rail. Hopefully that isn't measuring anything too low. It's measuring 500 kilo ohms. That is good, or 0.5 kilo ohms. What is it? It's not measuring super low, so I don't care. Yeah, it's 0.5 kilo ohms. That should be a healthy resistance for the PEX. So everything except the Vcore is good, right? So now let's figure out, try like narrow down how many power stages we have to deal with. So we're still going to be on the ground, on the ground with one probe. And now we're just going to check these input filtering capacitor pads over here. So like if we check this one, which this is input filtering for this power stage, and also like this power stage, like the thing is, most of your components on the card are somewhat parallel with each other, especially capacitors. Like all of the output filtering capacitors for the Vcore, those are all in parallel. And speaking of in parallel, like all of the inductors are in parallel with each other. So that's kind of the thing is like if you have one power stage fail, you have a, like if there's a lot of power stages and a lot of inductors, your life gets very difficult very fast because you won't know which specific one failed from just some quick measurements. But anyway, so that's not shorted. That's not shorted. Also good. Okay, so this power stage over here, if I didn't know if I didn't see the physical damage over here, this power stage would be suspicious, and I'd want to remove this, like I'd want to lift off this inductor, and I'll actually show that to you with the failed one, but yeah, I don't want to do a bunch of extra work for no reason, so yeah, but this power stage, if we couldn't see the bubble in the casing of the other one, then this power stage would be suspicious at this point. We don't need to check the memory filtering. We're going to check core over here. Also 2.5 ohms, so this power stage is suspicious as well. And this right here is 2.5 ohms, so, you know, but this is actually our failed power stage, so yep, that one's also suspicious. This one, no short circuit, so that we don't have to worry about this one probably. And over here, no short circuit, we don't have to worry about this power stage. So, now, we need to figure out so what I really, really hate about this VRM, and you've probably noticed at this point, is there's 8 power stages in total, but there's only 6 inductors. And the reason we have this horrible VRM configuration is because NVIDIA basically has these extra power stages not to handle more current, which is like what a sensible power delivery design would do, right? Like you have more power stages, you handle more current. No. This is because some of these power stages share the inductors. And the reason why you have these power stages, and mind you, like this is never ever, like nobody does this except NVIDIA. This is very much an NVIDIA invention because it's just like, why? Why would you do this? Why wouldn't you just add an extra phase? Anyway, or more like an extra channel, because if I'm not mistaken, the VRM controller on this is a 6-phase. So you can't actually have a 8-phase VRM with this. But what they're doing is they will change which of the two power stages sharing an inductor is connected to 12 volts so that they can sort of, because each power stage is connected to a different 12 volt source. Like this one is connected probably to this shunt resistor, whereas this one is probably connected to the PCIe slot. And so if you disconnect this power stage, this ends up being connected to our 8-pin, I think, and otherwise you can connect this power stage to the, or you can be connected to the PCIe slot. Also, I just noticed that there's a little bubble of solder over here. Why is that there? I mean, it's on the output side, so it shouldn't really do anything, but why is that there? Anyway, doesn't matter. What we're going to do is we're going to lift this inductor. Actually, no, I think we just have to lift this one. Yeah, because I'm pretty sure these two share this inductor. These two down here, I think, share this inductor, or it's these two that share an inductor. I am not sure. I hate this VRM. I hate this VRM so much. Partially because it blows up a lot. Partially because, well, actually, mostly because it blows up a lot, and then secondly because it's this weird mess of power stages and inductors that doesn't make any sense to anybody who doesn't work at NVIDIA. Actually, I'm not sure that... like, whoever at NVIDIA came up with this is probably the only person who thinks this is a good idea. Because they never... yeah, they never did this again. Like, they did it for a couple of the, like... I think they did it... they did it for a couple cards on, like, 700 and 900 series, and then never again. Because it's bad. Or maybe because... actually, I'm not sure why they stopped doing it. Okay, we have the wrong tip. Actually, we don't have the wrong tip for this. So what we're going to do is we're going to switch over to the hot plate. We're going to turn it on. We're going to set it to like 120 degrees. Because we are going to be hot airing that power stage off, and I want to, you know, not have to heat up one part of the board as much as possible. And first we're going to be lifting some inductors. So the way we're going to do that, I'm not sure which soldering iron tip I want to use. Can I? I think I'm going to use the smaller tip. Yeah, this is not really making it in there, so like I'm not getting good contact. So we're going to switch over to the, I think, 3mm chisel, and yeah, that's a lot better. So this is currently set to 355 degrees Celsius on that soldering iron. We're going to go for a little bit of flux on the inductor we want to remove. And yeah, I know I was just testing against that one. It doesn't matter. I was just checking that there's enough space. And we're just going to sit here for a while because GPU PCBs like this, like I would not be surprised if this PCB was at least 8 layers. And so it can soak up a ton of heat. An absolute ton of heat. So yeah, that inductor is not going to want to lift off for a while. And the reason I'm lifting the inductor is because if you couldn't visually identify which power stage failed, what you'd want to do is basically lift off all of the inductors that are connected to the shorted out part of the 12 volts. Well, you'd be lifting inductors and checking if the resistance of the Vcore, like if the Vcore gets disconnected from the 12 volts. So I'm just going to show you what that looks like when you do actually make that, when you do disconnect it. This is going to take a while. So right now my goal is just to, yeah, there we go. Lift. the inductor, like that. So now that it's lifted, right, now that it's lifted and not making contact, we shouldn't have a short circuit on 12 volts anymore because, I mean, yeah, we won't have a short circuit on 12 volts, or at least shouldn't. There's still a chance that, like, this power stage is actually internally also shorted to ground, which would be ideal, because that would mean the current would go 12 volts power stage ground instead of 12 volts power stage core, and then ground. But, yeah, at this point, we're just going to put the paper under this again, so that it's not shorted out against the metal of the hot plate. I can't put the multimeter on the hot plate right now, because it's hot. Actually, if I do it quickly, I think we might be okay. Melts his multimeter. There we go. And so if I do the check to this, and as you can see, that MOSFET is, I mean, that, come on. Okay, we're going to go to ground. Okay, we're going to... So it's no longer just reading 3 ohms, but instead it's like hunting around constantly, which I'm guessing this like power stage is like turning on and off. Like it's the issue with trying to multimeter active components is sometimes the resistance measurement itself is going to turn stuff on and off. So anyway, but we no longer have like that super low resistance on that shunt resistor anymore. So we now know that it's this power stage that failed. Yeah, so we're just going to desolder that and replace it. And when I say replace it, we have this donor card. This is a HD 7970 that I actually, it's a, is it a 7970? I think it might be an R9 280X, sorry. Yeah, so this is an R9 280X. This is a Sapphire card that I bought in a job lot of dead GPUs. It's very dead, or at least it's beyond my capabilities to repair, and also it doesn't have, like, the memory chips are trash, so I don't care. So anyway, we're going to get that heated up as well. This card uses Fairchild Semiconductor 6823C power stages, whereas 980 Ti's typically use 6823A power stages. The difference between these is they're both from Fairchild Semiconductor, but the difference between these two is that these are 60 amp parts, whereas these are 50 amp parts. And they use the same footprint, and they should just work, so we should be able to just grab these and put them on here, and the card should run. But we are technically downgrading the VRM, which is not ideal considering that the VRM on 980 Ti's explodes even when it's in perfect health, or with the ideal components, but at the very least we'll have all of the phases running instead of the VRM partially disabled. Technically you can sometimes get away with only having like 7 of the power stages still populated, but I don't like doing that, so... Anyway, also for the donor card, you can see I removed all of the input filtering capacitors because when we're hot airing off the power stage, I don't want to, yeah, deal with those. Cooking capacitors smell very bad. Very, very bad. So hopefully this power stage hasn't welded itself to the board. Oops. Also, for the little MOSFET that's burnt out on the back of the card, the current balancing thing, for that, we're going to just steal one of those same MOSFETs off of like a GTX 690. Speaking of which, I've just realized that I don't have that card near me. Oh, well, I'll go pick that up some partway through the video. So, let's get to removing that power stage. The hot air is set to 400 degrees Celsius, which is very hot. But I haven't had, like... components fail due to it yet, so... yeah, this is going to take a while. I have the preheating set to 120, so... could have probably set that higher. Also, doing it in this weather, not ideal. Okay, solder seems to be melting at this point. I really hope it hasn't welded itself to the board. Oh, it might have. Yeah, I think it did. Oh no. Yep. Yeah, it's welded. Oh wait, nope. No, okay, yep, it was. So that did weld itself to the board, which is annoying, because now we need to get the remains of that power stage off somehow. Well, that's no fun. Damn it! Yeah, so... Yeah, the high side MOSFET is still here. So that's very annoying. And the card's hot right now. I was really hoping it would just come off and we'd have like one continuous video, but nope. Yeah, that's not coming off. It's become one with the PCB. Like, technically in this condition, I mean, we still have to replace that current balancing MOSFET, but in this condition, the card is technically, like, you could probably turn it on. Yeah, well, that plan didn't work out, so I'm gonna go grab the 690 and we're gonna do the current balancing MOSFET. Hopefully that one hasn't also welded itself to the board, because it might have. Okay, so there's our 690. Those should be our current balance. This thing is very hot. So I'm just gonna... Okay. And so we need to wait for the 690 to get up to temperature somewhat. This is a donor card that got donated to the channel ages and ages ago. I first used it to repair a different dead 690, also that came at the same time as this one did. And since then I've been using it to repair GPUs because 690s just have so many components for NVIDIA cards. So, yeah, they're kind of perfect as a parts source. Okay, yeah, this one just came off, so that's nice. There's a little MOSFET. Now we're just gonna grab the replacement for it. I just need to check the orientation. Oh, lucky. It's the same orientation on these, so we're just gonna hit that. Okay, that came off. Oh no. So, the way I like to do this is I like to get the temperature, like the board up to the temperature that the solder starts melting, and then put the new component in place. Wait a minute. I'm turning it around the wrong way, aren't I? Yeah, okay. I'm gonna get the flux. Oh, it fell on the desk and picked up a bunch of gunk. Okay, fine. I'll put the hot air down. Just gonna put a bit of flux in there. And so, like, I want to minimize the amount of time that the, like, loose MOSFET spends in the hot air, which is why I'm doing it this way. So we're just going to get the board up to temperature first, and then put the MOSFET in. That way the MOSFET doesn't, like, get cooked, is my logic for doing it this way. Okay, the solder's melting. Okay, I'm going to add more flux to that. It's on there, it's just not at the right orientation. I'm going to get the mic out of the way. I accidentally bumped into the capacitors in the area, but I think the MOSFET is on there correctly now. So yeah, that took me a bit longer than I wanted it to. Yeah, looks good. Yeah, looks like it's on the right way, so we should be able to turn the card on at this point, so we will try that. Just gonna switch off the hot plate, and you're gonna get to not really look at anything for a bit, because I don't have a second camera angle set up for the test bench, so... Yeah, also we need to get this card to cool off a bit. It's very hot right now. Yep, very hot. So I have the card set up now, and I'm just gonna get the multimeter in place. It's still pretty warm, but it's not so warm that I'm like worried about turning it on and it immediately like catching fire. And it immediately caught fire. I don't know what I expected. It's a 980 Ti, so the VRM just exploded again. Evidently there was 2 bad power stages, not just 1. Or the other power... Actually, no, because this is the power stage that had the little, like, solder bubble next to it that I was like, well, it's on the output side, so maybe it just came over from the other one, but nope. That one was also dead. So that's great. Well, we're just going to desolder that one, too. Card's still pretty warm, so I'm just going to go for it. Hopefully this one hasn't also partially welded itself to the board. I should have... Like, the proper way to have tested the card would have been to put fuses on it, but... Oh well. This is exactly what happened with the Titan X Maxwell that dead one. Like I removed one. Actually, no, I got a lot further with that one. I tried to run Fire Strike, and then another power stage failed. Anyway, let's get this one off. Like, at this point, I'm kind of tempted to just replace all of them. Oh, I think this one's also welded. This one might be more... Yup. God damn. Come on. Yeah, this one... Oh, man, this is trashed. Man... I really wanted a reference 980 Ti for some testing that I want to do, but... Yep, it's stuck to the fucking board. Oh, this one took the entire ground pad. Yeah. It just took the entire ground pad with it. Stupid 980 Ti's. So that's... Well, I'm not putting that one back on. Let's see if that little MOSFET that I replaced died again. Oh no, the MOSFET survived, so I didn't screw that up. I am really tempted to just take everything off. But the thing is, I don't want to e-power another 980 Ti. Like, that's not the point of why I really wanted, like, a test card, that like, a vanilla 980 Ti for testing. The reference VRM, which, admittedly, maybe I should be doing that with a card that's in working condition, but, like, the problem with reference 980 Ti's is, like, I don't want to pay money for a card that does this on a semi-regular basis. Or at least I don't want to pay a lot of money for a card that regularly explodes. So, you know, that's kind of the logic behind, like, I'll just buy a dead one, fix it, do my tests, and then probably and hopefully it won't blow up before I finish testing. Plan failed. Blew up, like, yeah. I mean, I should have replaced that one when I noticed that there's, like, a solder bubble, but... Okay, now... There are no shorts anymore, right? Yes. Yeah, so we also don't have that, like, the multimeter isn't hunting the resistance value for that shunt resistor anymore. Is the core... Wait, are you kidding me? Did we just lose more MOSFETs, or is the core just so hot that it... So the thing about GPU cores is that their resistance changes depending on how hot they are, and so... Okay, it's just really hot. Yeah, so without the heatsink, the core was measuring 0.1 ohms. Now it's measuring 1 ohm. Yeah, and coming down as it still heats up. Come on. Oh, well, that, didn't go as planned. So, okay, let's check everything else again. 'Cause it's stupid, man. Like, I should have just put fuses on here. Like, I don't know why I thought, like, oh no, we're just gonna try to turn it on. It's not gonna blow up. No, it's a 980 Ti. It always blows up. Okay, all of the shunts check out correctly this time. Hopefully it was just these two. I really hope. Like, I want to get to the point of the card actually putting out an image, and then I'll worry about how I'll deal with the fact that the VRM is done, basically. So, yeah, anyway, I'll try to turn it on again. It's not quite as hot this time, so I can actually, like, barely pick it up. Well, if at this point another power stage blows, I guess I am just going to have to e-power the stupid thing, which I'm not particularly thrilled about. It's like the exact opposite of why I bought a reference 980 Ti. Because, like, if it was a Titan, then fair enough, because at least, like, you can't get a Titan with a good PCB. But 980 Ti's is like you have Matrixes, Lightnings, you know, good cards. And then there's this. Okay, moment of truth. Please don't catch fire again. Hey, no fire! I don't know if it's running, but no fire at least. And we're on GPU initialization, and it might be dead. Yeah, board's stuck on GPU initialization. So either we don't have core voltage right now, or the card is dead. Or, well, we could also have, like, no memory voltage or something, but... Oh no, the Vcore VRM just isn't running anymore. Okay, is the memory? Okay, well, we don't have memory power either. Well, that explains why it didn't catch fire, because nothing turned on. Five volts is present, but everything else isn't. Okay, well, I think I'll end this here because evidently I'm going to have to do a lot more work before this card, runs. Which is very, very... Oh, I think I know why it doesn't turn on. Right, I didn't clean. Oh, well. Okay. Well, yeah, but I think I'll end the video here because evidently I need to do a lot more work on this card. So hopefully you found this at least somewhat entertaining, if not particularly useful. Well, actually, it's useful. Like, the procedure is correct. The end result is wrong, but, you know. Don't just turn on the card after you've removed a power stage and like put fuses on the well, actually I don't think the fuses would have done anything. I think like be more diligent before you decide to try turn on a card that had a VRM failure. Even if it didn't like completely burn a hole through the PCB. Anyway, so yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I also have a Bandcamp, and there's links to all of that in the description. If you check them out, that would be much appreciated. And that's it for the video, so thank you for watching, and goodbye.